Okay, Assalamualaikum. In this video, I just want to highlight what is the important part for chapter 2, evaluation of experimental data. On the first part, maybe this one should be no problem for significant figures. Okay. Okay, for types of error, there are two types, determinate error and indeterminate error. For determinate error, okay, so since we know the sources, so this kind of error can be avoided. Okay, so this sources of error, it has three sources from determinates or systematic error. First is instrument, second is operative, personnel, third is method. Okay, first the instrument error might be from the equipment. Okay, the equipment is damaged, or from the glassware is not calibrated. Okay, actually glassware such as PERAK, pipette and volumetric glassware should be calibrated to ensure that the volume of solution delivered or contained is accurate. Alright. So from the instrument error, when we know the sources from instrument, we can correct it. Okay, if the equipment is fault, so it should be serviced. And if the glassware is not calibrated, or we must be calibrated to make sure the volume delivered is accurate. Okay, so for operative or personnel error, it comes from person. Okay, person who conduct the experiment. So such as post sample preparation means might be a person who conduct experiment. Okay, people comes from people who run experiment in lab. So in terms of post sample preparation, contohnya sampel salah timbang atau salah masukkan sampel macam tu. Okay, that one is come from person. Okay, and the other things might be from reading of meniscus. It is incorrect to read the PERAK, so the reading is error. Okay, color of solution at endpoint of titration might be over titrate, and then mathematical errors from calculation or bias. Okay, from person. Bias lah, contoh data lain tapi tulis lain. Okay, so from operative, so this error can be avoided, okay, by training and discipline experience from person itself. Okay, from method error, method from the might be the during the reaction. Okay, so the impurities of reagent from reagent, or the reaction might be too slow or incomplete, and side reaction occur. Okay, so proper method selection or deployment, or might be we have to repeat again the experiment. Okay, for indeterminate, since we do not know how where the source comes from. Okay, for example, when you weigh a sample using analytical balance, so the analytical balance is calibrated, okay, before run experiment, and then so from person there's no error. Okay, so but when you take the mass of sample, so might be the reading is not stable, or what, or might be the error comes from environment or vibration, or and then we cannot identify it. Okay, so we do not know where the source comes from. so difficult to correct it, okay, for this kind of error. Okay, next I want to highlight about the accuracy from the definition, and you can relate it with formula. Okay, so for accuracy, it relate with error. Okay, so the formula of error, if the value of error is small, so means high accuracy. Okay, so for precision, okay, precision is about how close the measure value to each other measurement. So it relate with formula deviation. Okay, for example, deviation, relative deviation. Okay, relative deviation, standard deviation. So the formula of deviation related with precision, meaning okay, how close the measure value to each other measurement. Okay, how close the measure value with each other measurement. So if that one, if low value deviation, so high precision, very good. So accuracy relate with error formula. Okay, so the meaning of accuracy, how close the measure value to standard or true value. Okay, so the good result must obtain high accuracy and high precision. Okay, both. Okay, next for the calculation, should be no problem. You have to remember the formula. Okay, under chapter 2, so the new subtopic for you is Q-test. Okay? So when we have an set of data from experiment, so one of the value seems different or far from each other. Okay, so either we want to remove the value of outlier or retain the outlier. So depends on the result of Q-test. Okay, so outlier means the value that are different or far from other value. So we suspect it as source or result of error. Okay, outlier or another words we call as suspected value. Right? So you have learned the video previously. So I want to add some more. Okay, the same step. Arrange that data in order of increasing or decreasing order. Okay, menaik atau menurun. So biasa saya akan buat decreasing order lah, menurun. Senang sikit, value high value minus small value. Okay, so first you susun data in decreasing order, and then find the all gaps. Okay, please take note this one. Find all gaps. Okay, beza setiap value. So the highest gap show the outlier. Okay, next determine Q by using formula, and then calculate by using formula A over W. And then you compare. So you must calculate Q experiment, and then from table write the value. Okay, and then the conclusion. If Q experiment more than Q table, so the outlier is rejected. Okay, because more than the value is more than standard, so we cannot use the value. So the suspected value or outlier should be removed. Okay, the important part for Q-test, you have to look at the number of observation, number sample, and how many percentage confidence. Okay, percentage confidence given in the statement of question. Number observation, you look at the question, how many sample. Okay, please after you arrange the value, so you find all gaps. Can you example this one value from question. Okay, so lepas dah susun cari semua gap ni. Okay, you minus this value with this value, you will find gap. So this one gap, which one is the highest gap? 0.31 is the highest gap. Okay, so it refer the value it outlier. Okay, usually outlier located on dia di hujung, biasa berada pada hujung hujung. Okay, lepas tu you teruskanlah untuk sampai dapatkan conclusion. Okay, so you have to do step by step for Q test. Okay, must have arrangement, find the gap, find the Q experiment, state Q table, and then the conclusion. Okay, for confidence limit, so it must be the limit. The answer must be in the range. Okay. I want to highlight. Okay. In test, okay, given value or given table. Okay, table Q test dengan table untuk confidence limit. So jangan tertukar lah untuk Q test. Okay, the table, the title critical value of rejection Q. Okay, so you look number observation and percentage confidence. Okay, so untuk confidence limit ataupun soalan confidence interval, bawa maksud yang sama lah. Interval tu dalam antara berapa sampai ke berapa range-nya. Okay, so the title of the table, value of T for degree of freedom for various confidence level. So confidence limit punya formula X bar, okay, min plus minus TS divided by square root N. So you kena cari mean T value from table. So macam mana nak tengok table? Tengok percentage confidence given in statement question and then degree of freedom. So if sample 4, okay, you kena cari degree of freedom berapa? 4 minus 1 is 3. Look at 3 at how many confidence. Okay, pada table sahaja you look at the degree of freedom, sample reduced by 1 and the percentage confidence. Okay, untuk dapatkan T value here. Okay. So nanti masukkanlah after you find mean, average, T value from table. S, find standard deviation and then divide by square root N. Tapi N ni adalah total sample lah. So kalau sample tadi 4, so here is you divide by 4. Okay. So you calculate, buat pengiraan untuk follow the formula and then the conclusion. So at how many percentage the true mean lies within from what range to what range. Okay, daripada berapa ke berapa lah. Mesti low value to higher value. Macam mana dapatkan low value? 7 minus after calculation TS square root divided by square root N. Okay, and then 2 from 7 plus 2.905. Okay, that's why the formula is S bar plus minus TS divided by square root N. Okay, you tak boleh bagi dua, bukan jawapan dia dua jawapan. Jawapan dia sebenarnya adalah antara limit ni. Daripada 4.095 to 9.905. So dia ada banyak probability lah jawapannya tu. Okay, so that's all for the highlight for chapter 2. Okay, thank you.